Working inside an electrical substation is serious business. According to OSHA interpretation, anyone who enters an energized transmission and distribution substation must be trained. With the proper training and knowledge, work within an energized electrical substation can be performed safely. This video will help familiarize you with some of the basic information needed to work inside an electrical substation. If you have any questions during your training process, don't be afraid to ask. After all, your safety may depend on it.
If you work within the confines of an electrical substation, you must receive specific training before you can enter the substation. OSHA has made this training mandatory for anyone who enters the substation. The training requirements are very specific. When working around electrical components and live wires within a substation, it is important to know the hazards and how to prevent injuries from occurring. To become qualified as an employee to work around energized electrical components, you must be trained in the hazards associated with exposure to live electrical parts, the skills and techniques necessary to distinguish exposed live parts from other parts of electrical equipment, the skills and techniques necessary to determine the nominal voltage of exposed live parts, the safe work distances and the corresponding voltages to which you will be exposed. Employees must be trained in and familiar with the safety-related work practices that pertain to their job assignments. The training needed to accomplish this objective can be either on-the-job training or classroom training, or both. The foreman or supervisor has the responsibility to review and approve or disapprove the qualifications of each employee. As part of your training, you will learn about electrical shock. A shock is a nerve reaction to an electrical charge through the body. There are many variables and factors that determine the severity of electrical shock. Factors such as the amount of current, the duration of current, the path of the current through the body, and the health of the victim determine the outcome of an electrical contact. You will learn about electrocution, meaning to be killed by electrical current. And you will learn about burns. Even a small amount of current can kill. The current drawn by a 7.5 watt 120 volt light bulb could be enough to cause electrocution. The most common shock-related injury is a burn. Burns suffered in electrical accidents can be of three types: electrical burns, arc burns, and arc blast or contact burns. Electrical burns are a result of electrical current flowing through the tissue or bones. Tissue damage is caused by the heat generated by current flow through the body. Electrical burns are one of the most serious injuries you can receive. Much of the burning can be internal and not seen on the surface of the skin. Arc burns are caused by electric arcing or the passage of substantial amounts of current through vaporized metals or carbons. Arc burns make up a large portion of the injuries from electrical short circuits and malfunctions. Electrical arcs can be up to 35,000 degrees Fahrenheit, which is about 4 times hotter than the surface of the sun. Another burn type is an arc blast, which is the pressure developed from instantaneous heating of the air surrounding the arc and from the expansion of the metal as it vaporizes. The hurling of molten metal often causes contact burns, and the pressure created also can hurl people and other objects considerable distances. As a qualified worker, you must be able to identify parts that you may encounter. Briefly, a conductor is any substance that offers little resistance to the flow of electricity. In the electrical industry, there are many types of conductors used in the various electrical systems: wire, cable, bus bar, or bus pipe, just to name a few. Conductors provide a path for the electricity to flow down. Copper and aluminum, because of their low resistance, are the two metals used primarily in the transmission and distribution of electricity. Many of the conductors used in the transmission and distribution of electricity are unprotected and bare, and therefore pose a hazard to anyone who comes too close. These bare conductors are held in place by insulators. Some conductors have an insulating cover that keeps the current on its intended path. An insulator is any substance that offers great resistance and prevents the flow of electricity. Some insulating covering used on wire and cable is made of rubber, polyethylene, polyvinyl chloride, and other synthetic polymers. The insulators used to hold conductors in place on transmission and distribution systems are made out of types of glass, fiberglass, porcelain, and synthetic polymers. The voltage rating of the conductor determines the insulation that is required for each application. The greater the voltage, the greater the insulation required. The insulation and insulators are intended to keep the live conductors and/or parts from contacting any ground or grounded part. If the insulation fails, a short circuit could occur where the current leaves its intended path. If your body is in that path, you could be injured or killed. Ground or grounded parts are connected to the earth or to some conducting body which serves in place of the earth. Ground conductors are connected to ground rods throughout most electrical systems and to the ground grid system inside substations. A ground grid is a system of crisscrossing conductors inside the substation just below the surface of the earth. The conductors are welded or connected at each intersecting location where a ground rod is also driven and connected. Check with the foreman, supervisor, or employee in charge of the substation to determine the voltages you will be working around. The voltage rating of electrical equipment is identified on the manufacturer's nameplate. This will help you identify the nominal voltage of the system you are working on or near, such as transformers or breakers. Do not open any cabinet door or climb onto equipment to read nameplates. If available, always check the station one-line diagram or blueprint drawings for the nominal voltage. It is not always possible to determine the nominal voltage by looking at the insulator size or type. However, it can help you to determine the class of voltage you are working around. Voltage breakdowns are 0 to 600 volts, secondary distribution voltage; 600 volts to 35 kilovolts, primary distribution voltage; 35 kilovolts to 69 kilovolts, sub-transmission voltage; and 69 kilovolts to 700 kilovolts, transmission voltage. When a qualified person is working in the vicinity of energized lines, whether in an elevated position or on the ground, they are prohibited from approaching or placing any conductive object without an approved insulating handle closer to exposed energized parts than shown in the OSHA-mandated table, unless the person is insulated from the energized part, the energized part is insulated both from all other conductive objects and from the person, and the person is insulated from all conductive objects at a potential different than that of the energized part. Employees may not enter spaces containing exposed energized parts unless illumination is provided that enables the employees to work safely. Portable ladders, if used, shall have non-conductive side rails. Working around energized equipment can be hazardous, and you must pay attention at all times. Do not enter a substation unless you have been trained. Be aware of your surroundings at all times. Assume that all wires are live and maintain safe work distances from them. Know the differences between a conductor and an insulator. Never use a conductive ladder near live wires. This has been a brief introduction to substation entry procedures. Remember that if there is anything you do not understand, contact your supervisor for clarification. And, as always, if you cannot do the job safely, then do not do the job.
In closing, the objective of this training is to make you aware of the electrical hazards, to familiarize you with the basic parts of a substation in order to help you distinguish the live parts from the other parts, and to make you aware of the different voltage classes available, and to make you aware of the minimum approach distances for the different voltages. Depending on your classification, knowledge, and experience, you must also know the safety-related work practices that pertain to your job assignment. If you have any questions, remember to ask your supervisor or foreman. And always remember, if we can't do the job safely, then we won't do the job at all.